technologies of the future, from electric vehicles to wind turbines, drones and robots, depend on powerful rare earth magnets and the materials they are derived from to turn energy into motion. Rare earths are not particularly rare, but they are difficult and expensive to separate and then transform into magnets. Production is also geographically concentrated. Currently, China produces more than 90% of the world's rare earth magnets. MP Materials is working to create a fully integrated magnetic supply chain in the United States to change this. It all starts at Mountain Pass, America's only scaled rare earth mining and processing operation, located in California's high desert. In Stage 1, ore is blasted from the floor of an open pit mine. Then, the ore is hauled from the mine and brought to the crushing facility. It is crushed into gravel. Next, the gravel is mixed with water and fed into a rotating milling machine where thousands of steel balls grind the gravel into a powder slurry. This slurry is mixed with selective chemical reagents and processed through a series of flotation cells. Once mixed, air is then injected into each cell. The reagents cause the rare earths to bind to the bubbles and float to the surface, leaving behind as much of the waste material as possible. After many stages of flotation, a rare earth concentrate is formed. At this stage, waste, or tailings, is transported to a facility that recovers and recycles the water in a closed loop. The dry material is then returned to ground. Around 5% of mining operations implement this environmentally friendly process. Mountain Pass is the only site in the global rare earth industry to do so. In Stage 2, rare earth concentrate is further refined and separated into individual elements. First, the concentrate from flotation is dried. It is then roasted in an electric kiln to oxidize the material. Next, the roasted concentrate is leached, pulling the high-value rare earths into solution. Most of the cerium remains suspended, improving the economics of the separation process. The remaining impurities are then removed, leaving a clean rare earth chloride solution. Finally, the rare earths are separated from one another. Selective extractants are used to remove individual elements from the solution. These purified compounds are then converted into final products. NdPr, the rare earth compound vital to magnets, is precipitated, washed of impurities, filtered, dried, and finished. Pure rare earth oxide powder is now ready to be transformed into magnetic materials. MP is constructing its first magnetics facility in Texas. Let's dive into that process. First, rare earth oxides produced at Mountain Pass are dissolved in a salt bath. This process uses molten salt and electricity to strip away the oxygen, leaving just the molten metal. Next, the metal is extracted, mixed with iron and boron, and poured onto a rapidly spinning copper wheel, where it solidifies into alloy flakes. The flakes are collected, made into a coarse powder, and then shot together to create an extremely fine powder. The powder is then pressed into a block, and a magnetic field is applied to it. This aligns all the particles in one direction, intensifying the alloy's magnetic force. Once aligned, the block is then densified in a sintering furnace. Finally, the block is cut to the desired shape and magnetized. Any scraps are recycled and reprocessed across the operation. Finished magnets are now ready to power electrified motion across the globe, ideal for applications where power, size, and efficiency are critical. MP's mission to fully restore the U.S. magnetic supply chain will provide resiliency and security, and ensure the sustainable supply of a component vital to economic progress.